Hey folks, we are about to do a quick little video on some urinary system organs. So what do we see here? We see a kidney that has been cut in frontal section. We also see an adrenal gland sitting on top of it. So obviously, here's the kidney. On top of that kidney, we got an adrenal gland. There it is. The adrenal gland is going to make hormones. Think about like epinephrine, norepinephrine, aldosterone, cortisol, sex hormones, and more. Kidney, of course, right there. Kidney is going to make urine. It's going to filter the blood to make urine. We see a ureter coming out of the kidney. We also see a variety of blood vessels. Some of the major blood vessels we can see are the abdominal aorta right there, the inferior vena cava right there. We got a renal vein right there, and we can see a little hint of a renal artery right back there. All right, but obviously, we are most interested in the kidney. And in this section of the kidney, we can see this region right here. This region right here. This region that I'm putting blue lines in. This region is called the renal cortex. So that region is called the renal cortex. That renal cortex is where urine is going to get made. Okay? Now, besides the cortex, another major region that we're going to have is this region called the renal medulla. And so what I'm going to do is draw a little arrow around this guy right here. That guy right there, it is a renal pyramid. So that guy right there is a renal pyramid. You should see a bunch of renal pyramids. How many do we see here? 1, 2, 3, 4, 5, 6. There are 6 renal pyramids in this kidney model. Those renal pyramids collectively equal the renal medulla. So the outer part is the renal cortex, which is where urine is made. Then this sort of middle part here is the renal medulla. Now, you may notice the renal medulla, these pyramids, they got all these lines in them. This is because they're full of ducts, and they're full of ducts that carry urine. Okay, one more thing about the renal pyramid. The tip of a renal pyramid, so this tip right here, this tip right here, this guy right here, each of these renal pyramid tips is called a renal papilla. All right, so the renal cortex is constantly making urine. Urine is constantly being made in the renal cortex, and then the urine flows down the renal pyramid, and it drips out of the renal papilla. Okay? That's the basic pathway right there. When you've dripped out of a renal papilla, you are going to be in this little cup right here. This little cup right here is called a minor calyx. So that little cup is called a minor calyx. Minor calyx means literally little cup. Every renal pyramid is associated with a minor calyx. So here's another minor calyx. Whoops, let's put it back on my pen here. Here's another minor calyx right here. That's another minor calyx. Boom. Now what you'll notice, these two minor calyces are coming together. When minor calyces come together, then we are going to make a major calyx. So this is a major calyx that I'm outlining here in green. That's a major calyx. Now, eventually, all the major and minor calyces are going to come together. And when all the major and minor calyces come together, so now we're in this region right here, when all the minor and major calyces come together, that is known as the renal pelvis. So, if we did a quick flow chart so far, we would start in the cortex, Then we go through the medulla, out of a papilla, into a minor calyx, into a major calyx, into the renal pelvis, then onward into the ureter. Okay, what else can we see in this model? There's one other thing. I could have mentioned this earlier, I guess, but, I didn't. The final thing we're going to see is this region of cortical tissue. Let's do this one right here. This region of cortical tissue in between the renal pyramids, and that region of cortical tissue in between a pair of renal pyramids is called a renal column. Okay, good. Let's get rid of all that. Let's go on to another picture. So now we've left the kidney. We're on the same model, but we've left the kidney, and we can see these ureters here. There's a ureter right there. Let me see. Let me pause. All right, so if we take a look at this guy, we can see a ureter here and here. And the ureters are going to the urinary bladder. Got a big, beautiful urinary bladder right here. This whole sucker is the urinary bladder. And we can see the ureters. We can also see two openings for the ureter. I colored one in yellow right there. Another opening for the ureter right there. I can also see an opening for the urethra. That opening for the urethra is called the internal urethral orifice. Okay, now what I want you to notice is that there is this triangle here, this smooth triangle, basically with corners that are openings. Two openings for the ureter and an opening for the urethra. And this triangle is known as the trigone. And it's pretty smooth. Most of the rest of the lining of the urinary bladder has all of these folds in it. You have met folds like these. There are folds like these in the stomach, in the gallbladder, in the vagina as well. And these folds, I bet you've guessed it already, these folds are rugae. Okay, so we got two ureters, we got a urinary bladder, two holes for the ureters here and here, a hole for the urethra called the internal urethral orifice, a region of smoothness called the trigone, and all the rest of the folds for expansion called rugae. Now the trigone helps funnel urine into the urethra. Here's the prostatic urethra. It's called the prostatic urethra because this guy right here is the prostate gland. So this is definitely a dude. We also see a vas deferens here and a vas deferens there, sperm carrying tubes. Okay, we're almost done. I know we're getting a little cluttered here in this model. Let's erase everything. We're almost done, okay? Bear with me. What we also see is this layer of smooth muscle. This is like the Muscularis externa of the urinary bladder. And we don't call it a Muscularis externa though. What we call it is the Detrusor muscle. The Detrusor muscle. Its job is to detrude, typo there, come on. Its job is to detrude urine. So the detrusor muscle detrudes urine. Detrude basically means to expel. Now there is one special part of the detrusor muscle that we gotta see and recognize. It's right here. Doesn't look any different in the model, but this special part is the internal urethral sphincter, which is normally closed to stop pee from leaking out. All right, that's it for video number 1. See you later.